So here is a surge protector that I bought, and as soon as I got it home and unpackaged, I heard a rattle in it, and it sounded to me like maybe a piece of plastic or possibly a piece of metal, maybe a screw. My mind started thinking, okay, there's a piece of metal rattling around in here, and no doubt it's gonna short and cause a fire in my house. So my first thought was, take it back, just exchange it for another one. But my second thought immediately after was, take it apart and inspect it. So I did that. It's held together by these little screws here, and there's 6 of them. And I just went out, got a little screwdriver, and took out 1, 2, 3, 4, 5, 6 screws, got them out on the table, and proceeded to investigate. And took off a plastic cover and saw there's a trim piece here, so I wiggled that out of the way, and the rest of it was all tight and solid and everything. So I did not find a screw, which is good, but I did find something that needed repairing, as it turns out. But where did that rattle go? And I'm thinking maybe it fell through. See these big holes here? Look at that big hole. What is that? Aha! That's where your ground plug goes through. So your ground plug goes through there and gets captured inside of this bar, right? There's 2 pieces of metal that sort of squeeze on it. So when you poke it through, when you poke your ground plug through, it squeezes on it. And that means that you can identify, here's the ground part of your circuit. So this goes back to ground, and if you follow it, there it is, there it is. Now you can't really see, actually I can. It ties into a wire here, it ties into this wire right here. So there's a green ground wire. And that gets soldered to this board, and this solder meets up and connects. So here's your green ground wire, and it goes into your wire and back to your service panel to be grounded. So that's pretty cool to realize. And then looky here, here's the hot side of the polarized plug. The short side is the hot side. So that turns out to be right here. So when you stick your blade in there, there's 2 pieces of metal, and the blade separates them, and it causes a friction fit, tension on. It bites down on that blade right here, actually. And so this is the hot side. So here's where the electrons are coming from. So you can see that because here's the black wire, as you would expect for a hot wire, and it comes in from here. So there's some circuitry here, and what this circuit is doing right here is this is the surge protector part and the on-off switch part of the circuit. So the power comes in with the black wire right here, comes in and gets soldered onto the circuit board, and then in the arrangement here it makes electrical contact with this black wire and goes out to this bar and provides current all the way over to this point where it just ends right here at this plug. But there's a pick point right here where you've got a smaller wire that pulls current off of this bar and sends it over to this arrangement over here. And this is where I found my problem. You might not be able to see, maybe you can't. On this white wire, there's like 1 or 2 strands of electrical wire that aren't connected. They're not really soldered right there. Well, what I found over here was about half of the strands were just sticking out in space. And I thought, well, that can't be good. Really sloppy workmanship. Half the strands were carrying the current, which means there was an increase in resistance because all of the conductors of this stranded wire weren't carrying current. Only half of them were. So that's going to increase resistance. And I'm thinking, well, I want to get all of those electrical conductors to be carrying current. otherwise the resistance in this wire might go up too high and this thing will melt, and again, I'll have a fire. So I found some shoddy workmanship, and all I had to do was go get my soldering iron and some solder and just put that bead on there, right there. And this is something you can do too. It's very simple, just a basic soldering iron. Here's a 25 watt unit at 120 volts. So you can do Ohm's law and the power law and figure out other information about this soldering iron. But there's a soldering iron, and then here, it's not plugged in, but here is, it says very fine electrical rosin core solder and dispenser. So it's handy to have this around, because then if you have to make a little electrical repair, you plug this in, it heats up, and you can just touch that solder onto that tip area and it melts it. And then you make connection where you want to solder, and you just melt this solder on like I did here. And then when you remove the heat, it just instantly solidifies. So now all of the conductors in this strand are carrying current like it's supposed to be. And then it goes over, the power goes over here. And so here you see a resistor, and here's a capacitor. These can shapes are capacitors. And this little guy's a transformer. So this is taking voltage, which is 120 volts on this bar, or from this bar to this bar is 120 volts across them. Well, this is taking current being pushed with 120 volts and sending it over to this transformer, and this transformer is stepping it down, stepping the voltage down from 120 volts to 5 volts DC. So you have voltage being stepped down from 120 to 5, and then you have a conversion happening from alternating current over here to direct current over here. So that's what's happening in here. So that you have a USB charger at 5 volts DC and 2.1 amps of current. So then over on the output side of this circuit, you see the white neutral wire, and it is soldered onto this neutral bus bar, which then meets up with this white wire, which comes over to this point on the circuit, and these two are connected by this solder right here. And so the return current to complete the circuit comes up and goes across here and comes down and back into the main supply cable, and then back out to the source, which is the service panel. There you go. Thank you.